Okay, so this is the second video of the third part of 1-3, the basic compound structure and nomenclature. And we had just, we said that our first step in naming ionic compounds was simply writing out the name of the element or the polyatomic ion. Okay, it could be a polyatomic ion, the ammonium ion, or it could be an element. It's usually going to be an element. Then we said that the second thing that we needed to do was check and see what type of column the compound came from, or the metal came from, so that we could see whether we needed to modify it, with a Roman numeral, because it was a transition metal. And so we can quickly check. Magnesium is in an A column, and you don't need to write this down, but I'm just going to put it here. Magnesium is in an A column. It's in 2A. Aluminum is in 3A. So I don't need to do anything with those. But mercury is a transition metal. Okay, so it's in a B column, and so I need to figure out some kind of Roman numeral here. And we said that our strategy was look at the formula to tell us what we needed, and we have oxygen at a charge of -2, and I have one of those, so that means I have a total of 2 negative charges. That means I have to have a total of 2 positive charges, and since I have 2 of these that are going to be splitting up the +2 charge, each one is going to take 1. So I need to have a Roman numeral 1 here. Okay, tin is in 4A. Zinc, however, is in a B column, so I've got to figure out a Roman numeral for it. Again, the practice is to look at the charge on the anion. Chlorine's in column 7A, so its charge is -1. But I have 2 of these, so I have a total of -2 charges, or 2 negative charges, which means to balance that I have to have a total of 2 positive charges. And I only have 1 zinc that's going to be creating these 2 positive charges, so that 1 zinc has to have a 2+ charge. Therefore, I'm going to put a Roman numeral 2 there. Iron is a transition metal. Okay, and we look at the charge on the anion. The sulfur is -2. I have 1 of those, so I have a total of -2 charges, which means I have to have a total of 2 positive charges. And there's 1 iron that's going to provide those 2 charges, so it has to provide 2+. So this is iron 2. Okay, in this one, this is a little bit different here. I still have a -2 charge for sulfur, but I've got 3 of them, so I have 6 total negative charges, which means I have to have 6 total positive charges. But 2 iron ions are going to be providing these +6 charges. So if 2 are going to be providing +6, one of them is going to be providing +3. Okay, the ammonium is a polyatomic ion. I don't have to do anything. Lead is in an A column. It's in 4A. I don't have to do anything. Sodium is in column 1A. I don't have to do anything. Copper is in a B column. Okay, and so I have a polyatomic ion here, SO3, and its charge is -2. And I only have 1 of these, right? I don't have 3 of them. I have 1 SO3. And I have to make sure that I use this as a whole unit, okay? And I only have 1 of those, so I have 2 negative charges. That means I have 2 positive charges. And I have 1 copper that's providing those 2 charges, so its charge is +2. So copper 2. Silver, again, I have a polyatomic ion, NO3, but I only have 1 of those, and the charge on NO3 is 1 minus, and since I only have one of those, I only have one total negative charge, which means I need one positive charge, and I have one silver providing one positive charge, so its charge has to be +1. So it's got a Roman numeral 1. And then the ammonium ion is a polyatomic ion. I don't have to add anything to that. Potassium is in column 1A, so it's not a transition metal. Aluminum is in column 3A, so it's not a transition metal. Lead is in column 4A, so it's not a transition metal. Tin is in column 4A, so it's also not a transition metal. Okay, so this is the way that we add the Roman numeral in if it's a transition metal. Okay, so go back to the presentation. I'm going to get rid of that. And then you'll also notice that if you click here, you can see this again. So you've got this in your notes to make sure that you've got the correct answers for your worksheet. Okay, so now I'm going to go back to my strategy, and now I've got a third step. Okay, so the third step in the naming strategy is to now look at the second component of the formula. This will often simply be an element, but it could also be a polyatomic ion. And how are you going to tell the difference? So here's how you're going to think about this. The first thing you need to do is figure out in the formula where the cation ends. Remember, it will usually just be an element, or it could be the rare exception, the ammonium ion, to help you. You can underline the cation so that you can visually see where the cation ends. And these are the just some of the ones that I selected from the list that we're working on. And so you can see that the cation ends right here with Fe. It ends with Fe2. It ends with the ammonium ion. It ends with lead. It ends with sodium. It ends with copper. It ends with silver. It ends with NH4. So everything else here then is the right thing, or the anion, or the second component. Okay, it's the nonmetal or the polyatomic ion. So what's left is going to be the anion, and if there's just one symbol, it's an element. If there's more than one symbol, it's a polyatomic ion. Now, you don't need to circle these in your notes or your worksheet, or write out element or polyatomic ion. Just notice that in FES, this is just an element. 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 Okay, but now I've got more than one symbol or more than one ion here. So this whole thing is a polyatomic ion, and the whole thing has a charge. The whole thing is a polyatomic ion, and the whole thing has a charge. Whole thing is a polyatomic ion. Whole thing is a polyatomic ion. So if the second component is simply an element, we just add, or it's just one atomic symbol, then the ending of the name of that element is dropped and the suffix IDE is added. So for example, if the second component in the formula is oxygen, we lose the -gen portion and add IDE, and that gets us the term oxide. If the second component of the formula is bromine and we lose the -ene portion and add -ide, we're going to get bromide. So those are the things that go in your worksheet there. What is dropped from the name of the element is not always predictable. It's mainly based on what sounds like it works most naturally. However, if you use the whole element name and then add -ide, I would not deduct any points. So for example, if you said oxygenide, I would accept that. So go back to the list and decide which second components are just elements, and add the second components to these formula names. Okay? Okay, so we're just going to write the names of the second component that are elements right now. And so the second component here is sulfur. So this is going to be sulfide. Second component here is oxygen. So that's going to be oxide. Second component here is oxygen, so that's going to be oxide. So mercury 1 oxide. Second component here is chlorine, so tin chloride. Zinc chloride. Iron 2 sulfide. Iron 3 sulfide. Ammonium sulfide. Lead oxide. Okay, so these are examples in which I just have an element and I just add IDE to the name doing that. Okay, so go back and go to back to the presentation now. And so if the second component is a polyatomic ion, then the name of that second component depends on the name of that polyatomic ion as listed in the polyatomic ion I've given you. So go back to the above list, and for those compounds for which the second component is a polyatomic ion, look it up on your polyatomic ion table and place the correct name in the blank. Oh, by the way, this is the finished product for the second components that are just elements. Okay, so let's open up this, and now we'll just, we'll do the ones with polyatomic ions. Okay, so if I look at my polyatomic ion table for SO4, I find out that that is sulfate. And if I remove one oxygen from that, I get sulfite. Okay, NO3 is nitrate. Don't know what's going on here. OH is hydroxide. ClO3 is chlorate. PO4 is phosphate. Lead chlorate, except I've got 4. Okay, so that doesn't mean 4 oxygens, right? That just means 4 chlor or hypochlorites. So ClO is what we've got there, and that's 2 oxygens less, so that's hypochlorite. And then I've got 4 oxygens here, and that's 1 extra oxygen, so that's perbromate. Okay, so that should be a good introduction into how to name these things. Again, go back to the presentation now, and there's a link that you can check your answers if we went through those too fast. Okay, close that link. So we're getting close to the end of the discussion here, so we'll have to stop and go to the next video.